Today, you are going to learn how to calculate the angle of impact of a blood spatter based on its size and shape. Now, to do this, we actually need to understand how to use a tool that we've never used before, a measuring device called a Vernier caliper. And this is a device that's 10 times more accurate and more precise than a ruler. This worksheet you're seeing here is going to be your end result. You've got two parts to it. You've got Vernier caliper practice that you're going to do using a different worksheet that I've posted as a PDF. You don't need to print that other PDF. You don't need to print this either as a Word document. You can just type right into it. And then the second part is going to be this angle of impact. Once you know how to use a Vernier caliper, I've actually gone ahead and made the measurements for you because you don't have one at home. So once you learn how to use the caliper, you can pretend you used it to make measurements and then do the actual calculation on how to calculate the angle of impact. So let me show you how we're starting. You're starting with this practice page, which essentially is a picture of the measurement made by a Vernier caliper. Now let me show you what a caliper looks like. This is a Vernier caliper. It is a measuring device that measures by opening and closing. And the cool thing about this device is that you can measure both the inside of something, like the inside of the scissors, or the outside of something. And there are measurements outside for when you measure the outside, and there's measurements for the inside when you measure the inside. We are only going to use the outside measurements because we're measuring the outside of a drop of blood. So we're only going to need the outside. So let me show you how to do this. It's very simple, but it is a two-step process. So if you don't pay attention, you are going to get lost. So I will take this fake blood drop here to demonstrate. Step one is going to be to place it around the edge of the blood drop, and then look at where the zero is on the caliper. Now, my zero is just a tiny fraction of a hair past the 18 mark. So I'm looking at this zero on the outside because I'm measuring the outside of the blood drop. And I'm looking at this scale. We have 0, 10, 20. And my zero line is just past the 18. It's between the 18 and the 19. So for this measurement, 18 millimeters is my whole number. Now to find the decimal, because it's not exactly 18, it's between the 18 and the 19. Now I look at these little tick marks on the top. And all I'm looking for is which one of these lines match up the best with the scale below it. And I can see this one doesn't match at all. It's way off. This one doesn't line up with the line below it. This one doesn't. This one is getting closer. This one is really close, but I think this one right here matches the line below it the best. Since this is 0.5, this is 0, this would be 0.1, 0.2, 0.3, 0.4, 0.5, this is 0.6. I don't care what the scale below it says. I just care that this line matches up with the line below it the best. So that's 0.6. I already got the 18 from the 0, so that measurement is 18.6 millimeters. Let me show you a different one to make sure we're good. Now when we measure a blood drop this way, when there is a tail to it or satellite spatter, we don't actually measure that. We only measure to the end of the drop. So I've got that measurement. I'm going to turn this sideways. Now this time my zero is just after the 25. So there's my 20, 21, 22, 23, 24, 25. It is not to the 26. So that length is 25. And because it's not exactly on the 25, I know there's a decimal. If this zero lies exactly perfectly on that line, it would just be 25.0, but it's not. So I am then going to look for which one of these little lines match up the best with the line below it. And you can see these ones up here, there is no kind of match with the line below it. This 0.5 is very close. This 0.4 is even closer, and this 0.3 is really close. So I'm gonna have to make a judgment call. Do I believe the 0.3 or 0.4 is closer? And I'm gonna go with 0.3. If you are a tiny off, I wouldn't have graded you down, but again, we're not gonna do this because you don't have a caliper at home. But hopefully you understand now how to read this, and what I want from you is for you to look at this worksheet. We're again ignoring the inside number. We're only looking at the outside. And you're gonna do the same thing I just did where you're looking at the 0. You're telling what's the whole number. So for this first one, there's 10, there's 15, 16, 17, 18. So it's gonna be 17 point something. And then if you're looking for which one of these little lines match up with the line below it the best, and that will be your decimal. So you're gonna look at these. You can just look at them on the computer. You do not need to print it out. Once you have the answers, that is going to be what you put up here under number 1, 2, 3, 4, 5, and 6. So that first part is just how do you use a vernier caliper to make measurements. The second part is how to determine the angle of impact. And I've given you a little drawing along with the formula on how to do it. And then it's a matter of just plugging in your calculator correctly. So let me get a calculator so I can plug that in. Okay, so I have a calculator here, my kid's iPhone. In order to do this math, you're gonna actually need the trigonometric function, so you're gonna have to turn it sideways to get those. So as you see here, in order to do this, you take the width of the blood drop divided by the length. That actually is considered what's called the R value. And we need to get the sine of the impact angle is equal to R. So we have to move this sine over to here. And the way you do that is take the inverse of sine. So how this works on a calculator is you're going to take your number. I'm going to make up some numbers because I don't want to use these ones. Let's say I have a width of 10 millimeters. So this length was, this width right here was 10 millimeters. Let's pretend. And let's use decimals because, you know, our vernier caliper is very accurate and precise. So let's say it's 10.2. So we're going to divide that by the length. This length is way longer. Let's say it's 30.3. And we hit equals, and that's our R value. Now, you don't need to write that anywhere. That's just for you in the calculator. Once we have an R value, we need to take the inverse sine of it, because in order to get this out of here, we got to do this to cancel out our sine. Well, when we put sine on the bottom, really what we're doing is the inverse sine, which is sine to the -1. So all we have to do is really simple on a calculator. You hit the second button right here, and it will turn our sine. See, it was sine before. We turns our sine to the inverse sine. So we just click that, and it gives us our angle. So this blood drop hit at a 19 point, and I'm going to round to 1 decimal, 7-degree angle. And that's our answer. So again, very simple. Width divided by length, and then take the inverse sine of that, and it will give you the angle of impact. If you ever try to take the inverse sine of something and it tells you you have an error, it's because you did the R value wrong. You always take the smaller number, width, divided by length. If you ever flip-flop those and you put the larger number in first, then your R number is going to be over 1, and you can't take the inverse sine of 1. It will give you an error. So if you get an error when you do inverse sine, you screwed up here. Hopefully between the practice on the vernier caliper, so you understand how that works, and then the actual practice on the angle of impact, you'll be able to complete this worksheet. If not, please come see me in the office hours Wednesday from 2 to 2:45.